Hey everybody, this is Alex Merced, and you're listening to my tech podcast where I talk about things like tech, software development, gaming, data engineering, whatever I feel like talking about. And today I feel like talking about semantic layers. Now, what is a semantic layer? Well, before I tell you that, of course, I want to make sure to remind you guys that if you are into data engineering and have not yet tried the Dremio free trial, head over to dremio.com/get started and do try out that free trial. I would love to hear what you think. So you can feel free to message me on LinkedIn or really anywhere you can find me to tell me what you thought of your experience with the Dremio free trial at dremio.com/get started. But with no further ado, let's talk about semantic layers. Now, what is a semantic layer? And to really kind of think about how the word, let's just think about the word itself. Semantic means meaning. Okay, so over time we've had things like semantic search, where basically we evolved search algorithms beyond just basic word matching and saying, okay, hey, which websites have the match with the word that I'm using in my search, but with trying to figure out, hey, which websites have the most meaningful results, okay, by taking a look at how the words are used and the greater context of the website. Okay, through, in this case, through hard-coded algorithms, but the idea was trying to find something that is more reflective of the meaning of what you're searching for versus just something that literally matches what you're searching for. So whenever you think about semantics, think meaning. Okay, so when someone's saying, "Oh, you're just playing with semantics," you're just playing with what words mean to say something that wasn't said or was said. Okay, so when it comes to data, so typically what would happen, and you'll hear this, like, it's something called medallion architecture. It's some people think it's a new idea, but it isn't. It's been around for decades. The idea of sort of like evolving your data in sort of three steps, where basically your data starts out as raw data. Okay, nowadays typically referred to as your raw or bronze layer. So it's just data that's been untouched. And the problem with like systems nowadays is that we use a lot of different tools to generate data, and oftentimes especially when you think about like IoT devices. So when I say IoT, that stands for Internet of Things. So I'm talking about like devices like your smart home or something like that. They are working with very limited hardware space, so they can't have like huge column names. You know, they need to store a lot of data, and they need to do it very compact. So oftentimes they store the data in ways that, if I were to just look at the data, it probably wouldn't mean much to me. Okay, so I mean, that's probably one of the most stark examples where semantics are lacking. Okay, unless you really know how the data is collected, which is not necessarily going to be what, you know, the end line data analyst at an IoT company is necessarily going to know. Okay, like the difference between what the person who engineered the software and the device versus sort of like, again, the person running analytics up front on the front lines are going to have two different sort of views of sort of the business. So typically what would happen is you would have your raw data, which is one, just kind of a mess stretched across lots of different sources. And then you would sort of model that data into sort of the entities you're running analytics with. So this is where like data modeling comes into play. So you would say, okay, hey, you know, if I was thinking about like a washing machine, like a smart washing machine, maybe like just an entity would be a wash. Okay, and then basically I'd figure, okay, hey, I have these details about the wash from the actual IoT device. I have this other data that I have about the date that I can match up with like weather, like weather data sets. So I can match up sort of what was the weather like during that time. You know, I want to match it all together to create sort of one sort of denormalized data set. So instead of having the data stretched across multiple data sets, I join them all into one entity or one event in my modeling layer, which is oftentimes referred to as your silver layer. Because not only does the modeling happen here, where you create sort of like these big sort of, again, entity and event tables, but also this is where you would do sort of a lot of cleanup type work, like, hey, detecting nulls, backfilling, figuring out, hey, which, you know, basically fixing the data, cleaning the data, so that we have not just data that is understandable, like well modeled, but well cleaned. Okay, so the idea is that your silver layer, once it's all set, should be data that's good to go. But again, it's generic data. So like I have a data on all my washes, but I'm not building a dashboard for all the data. Oftentimes you're building like BI dashboards for specific sort of questions. And with those questions, you develop certain sort of specific metrics from that data in that silver layer. And this is typically shows up in your gold layer, which used to be sometimes called a semantic layer, because the idea is that here, the versions of the data here in the gold layer, you're going a step further. It's not just clean model data, but it's data that has business context and business meaning injected into them, okay, for answering specific questions. So these would have column names that are much more specific to the use case, derived columns that were calculated from the other columns, specific to a specific use case, specific understanding that define things in the business. Okay, so from a modeling standpoint, and essentially this would originally, people would just kind of do this ad hoc, and then sometimes they actually wouldn't even like have a separate like third layer. They would just go into their BI tools and then just define these ad hoc per dashboard. So you might have a team using Tableau, and like 10 people on that team have now defined the same metric in Tableau 10 times. It's maybe slightly different, so you're getting inconsistency in the data. So the first step in sort of building sort of a semantic layer as like a thing was putting it inside BI tools. So that way multiple people using the same BI tool don't have to redefine the same measurement or the same metric multiple times. Then what happened is that multiple teams would use different BI tools. So you might have one team using Power BI, another team using Tableau, and now they've each of them with their own separate semantic layer, component or feature, both of them defining that same metric twice into two different semantic layers. So you run into this consistency issue, a problem again at scale. So then you start seeing sort of like doing semantic layers outside of the BI tool. So this Dremio has this integrated into its query engine. There's standalone semantic layers like at scale or cubed. And the idea here is that now you have this place where you can define these layers, and then Power BI and Tableau can connect to these layers and find the same definition. Okay, so in Dremio, you would create SQL views to define those gold level data sets, which also would have a companion wiki and lineage and lots of other context that'd be available there. And basically you would just connect that. So someone who's connecting Tableau or Power BI, they're working off the same definition of, January sales. Cool. So that was all great for like building BI dashboards, okay? And basically, and again, also the point of this was to create versions of this data sets that one were consistently defined, and that again, data sets that were semantic, understandable to your business line users. Like these are the versions of the data sets that your analysts would use. But this all accelerates AI, because AI benefits anything that made data easier to use for an individual human is 10 times as helpful for an AI to understand the semantics of that data. Meaning, and basically the better AI can understand the meaning of anything, the better it can interact with it. So this is where like semantic layers have a new life, a new sort of importance in AI, because they allow AI to be more efficient. Because if AI can understand your data up front, understand what your business metrics are up front instead of guessing, you end up with a lot less iterations of you having to have one agentic workflow that just goes through several different loops with the LLM to get accomplished, or then separate prompts because like the result of the first prompt wasn't quite what you needed. And I know at Dremio we did some research showing like, hey, what would happen when you use an LLM without a semantic layer, where basically you generally always had double-digit numbers of loops with the LLM. And basically, when you introduce a semantic layer, you kind of reduce those calls around like 47, 48%. So in that case, that's not just less tokens being sent to the LLM, and you generally pay for LLMs by token, but it's also less queries being run against your query engine, which means you're also spending less money on compute for your query engine. So overall, it can be a huge cost savings. And again, just taking a look at the numbers right in front of me, for LLMs, it would mean like 48% less runs to the LLM, so less loops, but it meant 86% less SQL queries, because it already knew what the definitions of the queries it needed were. It didn't have to redevelop them, refigure things out, rename columns, do all this context discovery. The context was there. Okay, and then this is typically all stitched together using MCP servers, where MCP servers if you're Dremio, you have the semantic layer built in, and you already have an MCP server that knows how to interact with the query engine and the semantic layer. But let's say you had a separate query engine and a semantic layer that was in some other tool, you would then have to create an MCP tool that knows how to interact with both. You would create your own custom MCP server, and that's what you would connect to your ChatGPTs, your Geminis, your Claudes, so that way you can just run analytics directly as an LLM prompt. Okay, and again, it would do it much more efficiently because it can grab the data from the semantic layer before running queries and have a better understanding of your data before it just starts willy-nilly running queries. And this is why semantic layers matter so much. And this is why it's really cool that Dremio has a semantic layer built in, and why, of course, you should try the Dremio free trial. Head over to dremio.com/get started to try out the free trial. But yeah, that was just sort of the thing that was on my mind today, semantic layers in general. Hopefully you guys enjoyed that. Make sure to share this with a friend if you enjoy it. Leave a review wherever you're listening to this. And thank you all so much. Have a great day and enjoy.